The vertex form is one of three ways you can write a quadratic function. We're going to go through just a quick summary of that vertex form and a quick check-in with what we know about a parabola or a quadratic function based on the rule that's provided in vertex form. So remember, vertex form is a modification of the parent function, x squared, that kind of original U-shaped graph. And the vertex form looks like this: a times the quantity x minus h squared plus k. So the main things that you know from this vertex form are this. The a value here is going to tell you whether or not the parabola opens upward or downward. So again, if the a value is positive, it should open upward, looking like a smile, and have a minimum vertex, meaning that low point. As I look at a negative a value, it's going to have a maximum vertex because it looks like a frown. It's flipped upside down or reflected over the x-axis. The other thing that we know about a's, when we started looking at our function transformations, we talked about that a, or that number a, tells us if our parabola is wide or narrow. We called those vertical stretches, vertical shrinks. So remember again, that vertical stretch, making it narrow, would have an a, let's say for an example, 8. It's going to be a number that's greater than 1. If I look at a vertical shrink, making that parabola very wide, like somebody sat on it, it would have an a value of 1/2, for example. You would have an a value that's greater than 0, but less than 1. The other thing that we know based on this vertex form is, of course, the vertex. So we can tell what the vertex is by using the h and k in the relationship. And then the last thing that we know is what the axis of symmetry is, where that invisible line is that goes right up through the vertex, making both sides of the parabola symmetrical. So let's take a look at these 3 examples. What I'd like you to do is go ahead and write them down, write down A, B, and C, and go ahead and pause the video, and then turn it back on when you're ready to check. Go ahead and pause now. Okay, so here are the solutions for A. So hopefully, as you went through and you were identifying everything you knew, I wanted to tell you that the A here, even though there's not a number out front, really it means 1. So that means it's not wide, it's not narrow, it's a standard width like the parent. It's almost identical, just shifted. When we did our transformations, we know that this parabola moves 2 to the left and 3 up. So when I write my vertex, it would look like this: -2, 3, and my axis of symmetry would be right at -2. Now, we didn't talk about this. Because the a is positive, it would open upward, having a minimum. Okay, let's take a look at B. So in B, I see the a value as negative, so that means it is going to open downward. It is going to have a maximum vertex at highest point. That 2 tells me that this parabola is going to be stretched, so this parabola is going to be narrow. And then if I was going to write down what my vertex was, because I don't have a k, it's not going up or down at all, I would write my vertex just like this: 1, 0. My axis of symmetry would be x equals 1. That would be that invisible boundary line that would tell us where that axis of symmetry is. Okay, let's take a look at C. This one I included fractions, but it's the same representation. My a value here is positive, so my parabola is going to open upward, having a minimum vertex. Because it does say 5, 6, if you go back over here to look at the example, it is going to be a vertical shrink. That means this parabola is going to be wide. It's going to look a little bit wider than our parent. And the vertex for this one would look like this. I'm going to take my h and k. It's going to be a -1/3, because this tells me that I'm moving 1/3 to the left, and then I'm moving down 2/3. So it should be a -2/3 for my vertex. My axis of symmetry, that invisible boundary line where it is cutting that parabola into 2 symmetrical parts, my axis of symmetry would be -1/3.